Hi, gang. STAT 1800, excuse me. What we're doing, this is lesson 4, the coreq material. STAT 1800 starts out, STAT 1800 and STAT 1800A begin with lesson 1, obviously, which I think is very straightforward. I think if you had the discipline to watch the videos, you did very, very, very well in lesson number 1. Lesson number 2 was hard. Even if you watch the videos multiple times, you probably struggled with lesson number 2. And lesson number 3 was challenging in parts as well. The good news is I think lesson number 4 is the easiest lesson in STAT 1800, STAT 1800A. So this would be an extra good time to watch the videos more closely, learn the material well, perform really, really well in your My Stat Lab assignment and the co-requisite material. The purpose of this video is to kind of brush up on some skills that we need to be good at confidence intervals. So I'll teach all the confidence interval and estimation stuff in the regular videos. So the purpose of this video is just to kind of brush up on some skills. Now, one of the things that we do in confidence intervals is we need to be able to find the middle of an interval. So let's think about what an interval actually is. So if we're on the number line, remember we have the positive numbers over to the right and the negative numbers to the left. So then, of course, we have 0 in the center. So if we take an interval, it's literally a part of the number line. Since this number over here has to be smaller than this number over here, because again, numbers to the right are bigger than numbers to the left, I can call this my low point, my low value, and this my high point, or my high value. My low value, my high value, my low value, my high value. It would be goofy to put an interval like this, 15, 2. The reason is the low number has to go to the left, the high number has to go to the right. All right, so what we have is we have an interval that in general will be in the form, scoot this over where you can see it, it doesn't matter if I can see it, of low minus high. To find the middle, all we have to do is just find the average of those 2 points, add them together, and divide by 2. So for the first example up here, 416, all I have to do to find the middle is take 4 plus 16 divided by 2. Now, I want to demonstrate that in my calculator. You know, we can all do 20 over 2. We know the answer is going to be 10. But sometimes, usually, we can't do that. So I want to show you how to put this in your calculator. So make sure the denominator is in parentheses. So in this case, we get 10 as expected. Now, for most of us, I'm sure you could do that one in your head. Now, the middle for the next one, we throw in a negative. Confuses things, makes things slightly more complicated, but not really. Negative 3 plus 15 over 2. Now, I can do this in my head, and maybe you can too. You can take 3 away from 15 to get 12. And you see that the middle is equal to 6, right? Okay, maybe some of you can't do that in your head. You want to be careful. So if I'm going to do this, I would go the same parentheses. I would assign the negative, assign the 3 a negative. So in that case, I use this negative and not this negative. Add the 15. Don't forget my parentheses because that operation in the numerator has to be done first. Divide by 2, and I get 16. Now the real test is when both of these are a negative. So I get negative 28 plus a negative 7 over 2, which is the same thing as negative 28. So I have a plus and a minus. So that's just a negative 7 over 2. I can see this as negative 35, though the middle is negative 17.5. All right, whatever. Maybe you can't see that, okay? So if you can't see that, this is the way you would enter this in the calculator. So again, the negative 28 has to be assigned a negative, so it gets the different negative sign. Now I'm going to come in and subtract. So I need this negative and divide by 2 to get negative 17.5. Now, what happens if you do this wrong? What if you put in the negative 28, use this, and subtract the 7, and divide by 2? What's going to give you an error because you've used the wrong negative. And what usually happens there, students flip out, and they're like, well, I've never been good at math. I can't, they start with whatever. Just use the right negative. Just use the correct one, and it works out fine. Okay, what happens if I do the correct negative, but I use the wrong negative here? Now, this is where things, this is where things really get wacky. Again, go to. It's not going to work because we have the wrong operation for what we're trying to do. So this small negative assigns a negative. The bigger negative does a subtraction. Now, we should be pretty much pros at finding the middle of an interval now, because all it takes is just adding the two numbers and divide it by 2. So now we want to switch distance when preparing to learn for confidence intervals and be able to find the distance from the middle to the endpoints. So first thing I got to realize is I can write this in a form that's going to be seen quite a bit for confidence intervals, because the purpose of a confidence interval is to estimate an unknown parameter. Now, that's not the purpose of this video. I teach all that in the instructional videos for the lesson. This is learning the content that's going to lead up to being able to master this stuff. But we have to realize that this interval in the context of confidence intervals means the same thing here, that our mean, mu, is somewhere between 14 and 80, with some few caveats. Again, I'll teach you that later. But what we like to be able to do is we like to be able to write this as the middle plus or minus the e, which is the distance. And I want to demonstrate that here. So to find the middle, easy, right? What do we say? Add the two numbers. So the middle here is going to be 47. All right. Now, what we need now is we need to find the difference, or I'm sorry, the distance from the 47 to the 14 and the 47 to the 80. Well, for the 14, if I just take the middle minus the 14, I get, 33? And for the other interval, or the other end of the interval, if I take the 80 and go back to the center, you'll see I get 33. It would be pretty goofy math if we were finding the center, which is 47, and the distance from the center to the end point, either one of them, was different, because then it wouldn't be the center. So the point I'm trying to make here is really all you need to do is just take the high number, the 80, minus your middle, and you'll always get this e. So we can rewrite this as the middle plus or minus the e, which is 33. Now, does that give us, is that equivalent to the 14, 80? Well, what's 47 minus 33? 47 minus 33 is 14. What's 47 plus 33? Well, that's 80, right? Put in the appropriate marks, and we get the interval that we started with. So again, not only do we want to be able to find the middle, we also want to be able to find the distance from the middle to the end points, what we call that e. Now, I think the hard part, the caveat to working with confidence intervals is we sometimes give really complex formulas that we need to be able to manipulate. Again, I teach you what all this stuff means later, but now I just want to review how we put this in our calculator. So how would we calculate p hat if x is equal to 12 and n was equal to 55? Well, it's pretty easy, right? Just put 12 divided by 55, and we get our p hat to be 0.218. Now, you would round according to the places that my stat lab request. So in this case, I'm just assuming it requested to go to 3. If it was 4, we would actually go to the 4th digit, which is a 1. I always have to investigate this digit over here to see if it's 5 or bigger. If it is, then this becomes 2. So in this case, that would be 0.2182. Oh, so 0.2182 if my stat lab requested 4 digits beyond the decimal. Now, these can get pretty ugly because there's a lot going on, but let's just say that z is 1.96 and p hat is 0.27 and n is equal to 500. How would we enter that in our calculator? Now, the first thing I would do is I would see that this 1 minus p hat can cause some problems if you put it in your calculator. So I'm going to go ahead and just calculate that here. Now, I can see that that's 0.73. If you can't, it's not a big deal. Just plug in your calculator. And if you weren't blessed with that quantitative skill, whatever, you got your calculator. I'm sure you're blessed with a lot of skills I'm not blessed with. Mine just happens to be, I've always been good at math. So now I'm going to just do plug and chug. So my z is 1.96. My p hat is 0.27. My 1 minus p hat is 0.73. And the n is 500. So if I can put this in my calculator without doing something goofy, then I've got all right, so I need 1.96 times square root 0.27 times 0.73 divided by 500, and then close the parentheses. Every bit of this has to be under the square root. If not, you're going to get the answer wrong. If you wake up tomorrow and you say, well, I just want to get all these answers wrong, I want to fail this material, then don't put that 500 in the parentheses. You'll get the wrong answer. So 0.0389. So helping a student the other day, and I told this person, I'm not going to say whatever, but whatever, I don't want to identify. I said, make sure you put the 500 in the parentheses. Here's what they did. I'm like, what are you doing? I just sat there and told you that the 500 has to be inside the parentheses. Well, they end up getting it wrong, right? Because they closed out what was in the square root to just the 2 numbers in the numerator. They didn't include the denominator. And I'll explain to you why I think they do that here in just a second. All right, the next one is very similar. So let's say that z star, and again, you don't know what let's do that. You don't know what z star stands for yet, but again, I'll teach it to you in later videos. Sigma and n So if we're going to put this in our calculator, first thing I'm going to do is write it out. So my Z star is 2.57. My sigma is 12. And my square root of 42 is there. Now here's a situation where I don't have everything under the square root. I just have the denominator. So 2.57 times 12 divided by the square root of 42. Notice I had to have two parentheses there. I have to have the 1 to close the 42 because that's what goes under the square root. And I need another one to close what I have in that expression. So 4.7587 if we're rounding. That's right? Yeah, if we're rounding to 4 places. This one is very similar. The only difference is sometimes in confidence intervals we have sigma, sometimes we just have S. So I want to run through an example there. Same stuff, really. Actually, this should be T star, but again, you'll learn that stuff later. So Z star, let's say it's 1.645. Let's say our standard deviation is 108. And let's say our sample size is 1,000. How would we put that in our calculator? Very simple. E is equal to Z star 1.645. Our S is 108. In our N, we need to take the square root of 1,000. So I'm going to put that over here. Put yourself to the test. See if you can get this. So this is what I get. 5.6181. All right, gang, the last one. Sometimes we're asked to find a sample size, N, instead of finding this E, this distance that I've talked about earlier. In this case, we sometimes get some kind of messy stuff that we have to solve. So let's say that Z is 1.96. Let's say that sigma is 48. And let's say that our error is 3. How would we put this in the calculator to get in? So notice everything needs to be squared. So the Z is 1.96 times the 48 over the 3. So put yourself to the test there. Just quickly grab your calculator. So 1.96 times 48. Well, I've got big fat fingers for some reason. I get 983.45, and these numbers, these types of problems where you're solving for N, we always round this up to the next number. So in this case, it would be 984. Even though it doesn't technically round to 984 because this number is not 5 or bigger, it would, under traditional rounding rules, round to 983. But anytime in statistics you're solving for N, you always round up. Even if this was 983.00001, which would clearly be closer to 983. In statistics, when you're solving for N, you round up to 984. All right, let's see who's with me. Sneaky quiz. Email to Dr. Darborough. Shouldn't even give you this because You should know this by now. So we've got an interval, negative 11 to 39. If you email me the answer, I want the middle and I want the distance. So two things. Email this to me before the assignment for this lesson is due, and you get 25 out of 25 points. Don't email that to me. You get 0 out of 25 points. All right, gang, hang in there. Take care.